We have successfully watched up to this moment, and then we have seen how we generated these three equations that will be solved simultaneously. What we need to do here is very simple. We are going to concentrate on equation 2 and equation 3. I repeat, we are going to concentrate on equation 2 and equation 3. We must make sure that the value of I4 normalizes with the value of I4 in equation 2, okay? With that, we'll be able to apply elimination method. Before I continue, remember to subscribe. Give us some thumbs up. Share with your friends, students, and networks. Don't forget to put on the bell button for constant notification. All right, let's go into this. So for us to be able to normalize this, we multiply equation 3 with minus 0.4, right? Let me write it well. For us to be able to normalize the third equation with equation number 2, we multiply. We multiply equation 3 with minus 0.4. So take note of this. So if this minus 0.4 multiplies, this is going to give minus 48I1. It comes here, multiplies this, going to turn this to plus 56I2. All right. So we take it again, minus 0.4 multiplies this, going to change this to minus 40, all right, 40I4, all right. So remember we have this should be equation, all right, we call this equation number 4. We have generated new equation, right? But it doesn't end there. It doesn't end there. We need to consider something. Now we have generated the fourth equation. You can see equation number 2 and equation number 4 have the same value at this point. So the next thing we need to do is to apply simultaneous elimination method, okay? Simultaneous elimination method, or elimination method in solving simultaneous equation. So by the time we say, can we just bring out the two equations now? Or we just go straight and solve? So minus 30I1 minus 48I1. Of course, the next line will show that this will give minus 78I current 1, right? So we take again plus 20 current 2 plus 56 current 2 is going to give plus 76 2, right? All right? So we are taking this next one, plus 40 minus 40, of course. Completely everything here is going to be 0, right? Okay? And remember it is equal to 0 at this point. So we don't have anything left here, right? So that's what it means. We have succeeded in reducing equation 2 and equation 4 to just two terms, current 1 and current 2. Okay? So that's what we've just done. The next thing is that we are going to make I1, current 1, the subject. We are going to make current 1 the subject and then substitute in equation 1 because we have not used equation 1 in the first place. All right? So let's go into that. By the time we make current 1 the subject, it becomes, watch out, becomes current 1 is equal to 76 becomes minus 76, right? All right? And then I2, right? All over, this is minus is coming here, minus 78, all right? Okay, because it's coming from minus, so this is going to take care of this, and we are left with current 1, the value of current 1, or we can still put it here, 76 I2, all over 78. Good. Therefore, I1 can be evaluated as 72 I2 all over 78. Okay? So we now have develop that by the time we simplify this quantity, we will have the current one value. But that is not our target. Our target is to substitute for current one in equation 1 and then solve for current 2. That's our target. So we keep this. Take note of this. We keep this and then substitute it in equation 1, right? So let's see how it goes. Substituting. Substitute current 1, all right, in equation 1. Equation 1. So that's what we're going to do. We are going to substitute current 1 in equation 1, right? Substitute for current 1 in equation 1. If you so set to be, all right, we're going to do that. Substitute for current 1 in equation 1. So let's go ahead and do that. Our equation 1 is 10 is equal to 10I1 plus 20I2. That's our equation 1, right? Good. So the next thing is for us to quickly substitute for equation for current 1. Have our 10 here, all right? Okay. The value for this current 1, look at it there, is 76. That means brackets 76I2, right? All over 78 plus 20I2. So we have successfully substituted for current 1 in equation 1. That is it. Okay, by the time we clear out, if we clear out as suppose, we are going to have, at this point we're going to have 10 is equal to 760 I2 all over 78 plus 20 I2 all over 1. Okay? Very, very interesting, right? So look at it. So the next thing, we find, what do we find here? We find our LCM, that is 78. And that goes that way. We have 70, that is 10 at this point, 760, all right, I2, right, plus 78 is going to multiply all this, all right, we have 78, 20, I2, bracket close. So that's what it's going to be. However, if we succeed, further simplification, if we further simplify this, it means that further simplification to avoid wasting time, I2, the value of I2 is going to be 0.3362 amps. Alright, that's what it means. Therefore, the value of I2, that is current 2, is going to be 0.3362 amps. Now, if there is any doubt here, okay, I want you to do me a favor. Use a calculator or any material or any tool that you want to use. Do this, simplify this, okay, and then divide by this. Make current 2 the subject, all right? Make current 2 the subject, and then check if your answer corresponds with my own answer. Put your decision, put your answer in the comment section, and then let's discuss it further. Alright, so now we have found current 2. We need to move on to find current 1. Okay, so what do? We have found current 2 to be this. We go back again to equation number 1. Go back to equation number 1. Go back to equation 1 and substitute. All right? Substitute for current 1. Right? That is it. So we're going back to equation number 1 to substitute for current 1. And equation number 1 is 10 is equal to 10 I1, right? Okay? For current 2, not current 1. Substitute for current 2 for us to find current 1. Alright? Then I plus, remember it's plus 20 I2. We already know the value of this, okay? We already know the value of this. So what do? We make current one the subject and substitute. Making current one the subject is going to be I is equal to, alright, minus 20, okay? Minus 20 I2, right? Minus 10, right? This is minus, okay? Then all over 10. Good. So that's what it means. So if we have this, we have current 1 is equal to, check it again, we have current 1 is going to be something on 0.3, right? 3672 amps. By the time we evaluate properly, we're going to have this. So that's the value of current 1, all right? So let's see once again how it works. If we have, this is 20, if it comes over this side, it becomes minus, all right? And remember we have, okay, becomes minus here. And then we are making current 1 the subject. Don't forget, this is going to be the subject. So if we do that, first of all, we take this to this point, becomes, this should be plus, somewhere here should be plus, okay? Yeah, very correct. So we take it that way, and then we have this. I think we should have a minus here. That is the answer for this. That's the value for current 1. Now we have found current 1. We have found current 1 to be 0.3672 amps. All right. We have found current 2. Where's chalk? We have found current 2 to be 0.3362, right? 60 amps. All right. So how do we now find current 4? Okay. We are looking for current 4. How do we now find it? Since we have found all these things, okay? That's the next thing we need to ask ourselves. How do we find current 4? So we are going to find current 4 by recurring our previous equation, right? Either this or that can go. So let's look at it very well, because we are looking for current 4. So we can make any of this. We can use either this or that. Well, let's use equation number 2. We're going to use equation number 2 to find current 4, right? So if we do that, equation 2, all right, is given as 0 is equal to minus 30I1, right, plus 20I2, and then plus 40I4. So if we substitute, we are making current, if we substitute, it means that I4 is equal to 30, okay, 30I1, right? This becomes minus 20I2, and then finally what do we have? All over 40. Okay? Now it's time for us to substitute the values of I1 and values of I2 for us to arrive at current 4. So we are going to do that right away without wasting time. Let's do it here. If we now substitute the values of current 1 and the values of current 2 in this equation, we have current 4. So current 4 can be found as this 30 for current 1 is 0.3672 close. Current 2 is, this is 20 plus 20. Okay, minus 20, not plus. Minus 20. I2 is going to be 0.3362. Okay? All over 40. Okay? That is it. So it means that current 4, therefore, if we simplify further, current 4 is going to be I4, right, is equal to Watch this, we simplify this, we have 0.07768. So this is what it should be, right? So we have succeeded in finding current 4. We have also succeeded in finding current 2, and then in finding current 1. So the rest is very simple, okay? We need to find current 3, we need to find the total current, okay? So how do we now find the total current? How do we find the total current? Total current, right? Total current flowing. Total current flowing is very simple. We're going to find that by using I4 is equal to I2, because in total current we have the first one splitting, that is I1 plus I4. So we're looking for total current. Total current is going to be found using this I1 plus I4. So we substitute accordingly. If we substitute for I1, we have 0.3, that's I1 here, 0.3672, 3672, and then I4 is 0.0776. So this is going to give us the value of the total current in that. So if we do that, it's very simple, and I want you to put on your calculator, just simplify this. 0.3672 plus 0.0776. So if we do that, what happens? 0 goes with 0, we have 0.0 point. And the next one we have 3 is going with 0, we have 0.3. Alright, 6 goes with 7. Alright, but we should have started with 1, 2, 3. Okay, we should have started 2 goes with 6 is going to be 8. Alright, 7 goes with 7 is going to be 4. And then we have 1. 8 goes with 6 is going to be 14. Alright, and then we have all that going to be 14. Add 1 here is becoming 4 again. This is going to be 4. So the answer is going to be 0.44448 amps, right? Therefore, total current is equal to 0.444 again 8 amps. All right, we have succeeded in finding the total current here. The next thing we are going to do is to find current flowing into junction 5. Of course, current flowing into junction 5 splits into current 4 and current 3. Of course, it's current 4 and current 3 that come together and they flow into junction 5. So it's very simple for us to find that. What do? We are going to clean up somewhere. Now we have used this equation to find what we are looking for. It is time for us to clean it off and arrive at our final answer and then move on from there. Before I continue, if you have watched up to this point and you have found pleasure, you have found value in this, why don't you subscribe? Give us some thumbs up, all right? Share with your networks, friends, students, and then remember to put on the bell button for constant notification. So we move on again. Current 5 can be found using current 5, you're going to find this using the value of current 4 plus the value of current 3. Yes, very simple. So we substitute quickly. Current 4 is there, 0.0776, all right, plus current 3, which is about to be determined. Okay, we have not determined the current 3. So how do we do this? Current 3 is going to be current 1, okay? Current 1 minus current 2. So let's quickly do that. If we do that, we have current 1 minus current 2. 1, okay, minus current 2. So what do we get? We have, we substitute the values of these currents quickly. Okay, we do that quickly. Current 1 is 0.3672 minus current 2, which is 0.3362, bracket close. At the end, we need to find the value of current 5. And I want to leave that for you. The unit is amps, okay, is in this bracket. The unit of current 5 is amps, okay? And we're going to leave it at this point. I want you to use your calculator, okay? Use your calculator, simple addition, subtraction, your add base, you subtract from this and then add to this. Whatever it gives you, I want you to put it in the comment section, all right? That the value of current 5 is this. And be convinced that these steps that we have taken so far, worth it, all right? Once again, I want to thank you, but remind us, as a reminder, let us recap what we have done. We use those equations generated to find the value of current 1, and this is it. Find the value of current 2, this is it. Find the value of total current flowing in the system, and this is it, all right? And then, we should have found the value of I3 before this, but with this, we can find the value of current 3, okay? And finally, the value of current 5. Also recall we found the value of current 4. So we have done well. We have gotten all, right? So simple addition or subtraction here will give you exactly the value of current 5. Thank you so much for watching.